Right, good morning everyone, and sorry for the delay from my side. I was waiting at the administration block and they said they have not opened the doors. I think I put a message as well. Sorry about that. And then last time we started this module on big data analytics, but before we talk about big data analytics, I think we should know what data analytics first. And my plan is to start slowly the data analytics part, and then we will discuss technologies that we use for big data analytics. So I think last time we discussed some basics on what we do, different kind of data analytics problem. And today I'm going to talk about some algorithms. I will also show you some implementation which you might not understand completely, but after you exposed to Python for some time, hopefully after 2 sessions time, you should be completely understand the examples. Right. Having said that, let me start today's session. The morning, if you miss my previous classes, we will start morning sessions. We will have theory classes, and then evening sessions we have hands-on practical classes. So that's how we have organized. Right. Having said that, some of the basic algorithms that I am planning to discuss with you starts from OneR algorithm, and then decision trees, decision rules, nearest neighbors, and naive. These are very basic algorithms, and anyone should learn like data analytics. You should know these algorithms. That's the basis. And I'm going to go into deep, meaning like you should understand how you might actually generate these algorithms, meaning like the outcomes. Why I am so, and after some time you can switch to software and you can do the analytics, but you are not really worried about what is happening inside, which is my approach is slightly different. Right? So at least for the simple algorithms, I will go into detail. We will by hand we will solve the answers, and then we will use software to verify our answers. So that's the approach that we used to have. Right. So having said that, hopefully I can at least finish first 2. So that's the plan. Right. Now the first thing is, whatever data analytics problem you are at hand, normally in the field they say that simplicity comes first. The idea of this is most of the time these data analytics problems at hand can be solved. You can have a decent solution with a very simple algorithm. So usually we recommend that you start with a simple one, and if you're not satisfied with the outcome of the simple one, then you can go for complex one. Right? For example, not applying like deep neural networks for all the problem at hand. Right? Right. Now, why we recommend simple algorithms? Most often, this works very well, and this has shown in studies, even in practical scenarios. And also, when the algorithm is simple, you can completely understand what is going behind, which is another plus point with very simple algorithm. So there are many. By the way, we are recording the session, so I can share with you later on. So there are many kind of simple structures, and today we are going to witness some of them, right? And the very first one we are going to discuss today, we are using only one attribute or one feature, and the assumption is we assume that one feature is enough for make any predictions, right? So that's what we call OneR method, which is the first one we are going to look at it. Second one, now completely opposite. We assume that okay, all attributes equally contribute to the making the decision, which is the basis for naive Bayes. Third one, a weighted linear combination. I think in financial domain, you might have seen this again and again. Right? Most often you go for regression analysis where you have a weighted feature, linear weighted features, and definitely that is what we also starts with, especially in regression domain. Fourth one we call instance based. Instance based means we are not going to build any model as such, but we use data to make predictions. Right? So we use data, so no model. Last time I have showed you some models in decision trees, decision rules, and so on. But the instance based algorithm, we will see that there is no such model. We will use data as it is. Right. The last one is simple logical rules, which you have already seen, like if-then kind of a rules we will use. These if-then rules are very useful for you to see the insights. Right. However, these algorithms may not work in all the domains. Right. Some are better than the other methods in different domains. So in medical domain, some methods are popular than any other domain. In financial domain, for example, may prefer some models, right? So we will discuss the details later on. Right, now let's look at like how you may generate very simple rules, right? So OneR method is actually, it's not very popular. You may have not heard about it, but I think in my lectures I used to start with this one because this is one of the very simpler algorithm to start with. But actually there's a 0R as well. This is OneR. I will explain what that 0R means. But what we are going to learn here in OneR is we are going to learn a single level decision tree. So last time you have seen a decision tree and it has only one level decision tree. So you will have only one attribute, and we will see today how we can come up with this one decision rule. Right. So here is how it works. This is what we normally call in programming. We used to discuss how you build something. So this is the same thing. I will list the steps what we are supposed to do when we use this simple algorithm. Right. Now the first step that we will do is we will take each attribute at a time, and for each attribute value we create a branch, right? And then for each branch we will assign the most frequent class, right? If you didn't attend my session last time, the class means in classification problem usually we are trying to predict something. I will show you a data set in a minute. Like we have a weather data set. We are in different weather conditions. We are trying to predict whether to play a particular game or not. So class attribute means that particular gameplay, right? So you assign for each attribute value that, right? Then you know that whenever you make decision rules, there are always an error rate. So similar here as well. Once we create the rule, we calculate the error rate based on the data, right? And then finally, what we are going to do, we are going to choose the attribute with the lowest error rate. Right. Now let me show you how we are going to do that. Right. One thing is we are going to assume nominal attributes. Nominal means categorical. which I am going to show you now. So here is the data set. If you missed this last time, right? So in this data set, we have outlook, temperature, humidity, windy and clean. So these are called attributes. So outlook is an attribute, temperature another one, humidity another one, windy another one, and we are trying to predict play. So you can also find your own data set for the similar task. So a doctor can collect the details about the patient, and then the class will be a particular disease. In financial markets, maybe like if you are looking for profitable ones, profitable shares maybe, the class could be you deciding whether it's a profitable or not. Whether your investment is profitable or not after some time, let's say a 1 month period time. So you can model like this, you can collect the data for that. Right? In a e-commerce, we can make a data set whether the particular customer is going to purchase the product or not. Because you know that when you have a website, company website, people come in, they are not going to check everything in your web interface. Actually, in data mining, we can collect all the information. When your customers visiting your website, you can see how they actually interact with your website. You can even improve that, right? You can even predict whether a particular customer will click on that link or not, right? So that is the place that we can actually model the problems, right? Now in this problem, based on these different weather conditions, we are going to predict the whether that particular game, whether you are going to play yes or no. Right, now we are going to learn OneR algorithm. Right, so we have 4 attributes and 1 class attribute, right? So we will go 1 attribute at a time. So that means we will start with outlook first, right? We will start with outlook, right? For each attribute, then for each value of the attribute, which means for each value means in outlook we have 3 values: sunny, overcast, rainy, right? For each attribute value. So what we are going to do, we are making rules how you count how often each class appears. Right. Now for example, let me start with the outlook sunny. We have outlook sunny. When outlook is sunny, look at the class attribute, it's no. Second one, again no. Then here we also have 1. Right? So look at what is the outcome, again no. Fourth one, this time yes, this time also yes. So for outlook is sunny, we have 3 no classes, 2 yes classes. What is the most frequent one? Yes? Most frequent? No. So that means when outlook is sunny, most probably you are not going to play the game. Similarly, you do this for the others as well. Right? You find the most frequent class, make the rule assigned to that class to the side rule. Calculate the error rate for the rules. So for all the 3 attributes, we do the same thing and we calculate the error rate. And finally, we are going to choose the rule set with the smallest error rate. Okay? Right. Alright. You have to have that data set with you to understand. Can you take the data set from the notes? I think I have shared you the notes. If you can have that table with you, the data set, it is easier for you to understand. For the exam also, you are going to get the similar question, and you have to put up a table like this, and it's an open book, which means all the notes you can use it, right? But just you should learn how to come up with this, right? Now I'll go back again. Now in this data set we have 4 attributes. We have outlook, temperature, humidity and windy, and we will have play, right? And then we have to calculate for each attribute value. We have to count the frequent class, right? So you always starts with the data set. You look at for each attribute value, right? So I think better I will start with the whiteboard. Let me start. Let me first set up the whiteboard and